All right, so in this unit, we are going to be looking at sequences. Sequences is something that you're fairly familiar with. We're going to ramp it up a little bit, and then what's going to happen over the course of this unit is we're going to move from sequences into functions, and you're going to see how the two of those are connected. But before we do that, we're just going to work on sequences themselves, and we're going to sort of take it up a notch from what you're used to doing in the past. The good news is you're typically very good at figuring out what the sequence is, what the pattern is, and so we're just going to take that skill and we're going to expand on it. So what do we have here? So a sequence is a collection of terms, okay? So this right here, this would be called a term. And terms are numbered. So this would be our first term, our second term, our third term, our fourth term, our fifth term. And we usually refer to a term as n. Okay, so this would be n. So this here, give me 1 second, let me get there. This would be n equals 1, n equals 2, n equals 3, and this is the first term, second term, third term. That's how we discuss these things. And so the terms are the numbers in the sequence. So what's going on in this particular sequence? Well, it's 4, 7, 10, 13. Most of you very quickly figured out this is a plus 3. The pattern here, so to speak, is plus 3, so on and so forth. So we want to be able to represent this using a formula, and it might be easiest if we look at a table first. So if we look at the table, let's call this sequence, we name all our sequences. Capital A is a common name, and then lowercase f is also a common name, but we can call them pretty much anything we want. So let's use capital A. So in this table, what I want to show is I've got n, and then the output, the actual term, so this would be the term number, 1, 2, 3, 4, 5. That would be the term number, dot, dot, dot. And then A sub A of n, okay, written like this, and that's how you say it. This is not multiplication. This is A of n. That's how we say it. That's the actual output. So in this case, it would be 4, 7, 10, 13, 16. You can kind of think of this like an x value, and this is like a y value. If I were to rewrite this a different way, isn't it true that this is 4 plus 3 times 0? So 3 times 0 is 0, 4 plus 0 is 4. Isn't that the same thing? I could rewrite this one as 4 plus 3 times 1. I could rewrite this one as 4 plus 3 times 2. 4 plus 3 times 3. 4 plus 3 times 4, so on and so forth. Okay? So here is a way to generate any term in the sequence. What do? It looks like if I ask you for any term in the sequence, like if I ask for the fourth term, you take my starting value, which is 4, and you add to it 3 times the term number before it. So for example, if I want the fourth term, I'm going to do 4 plus 3 times 3. If I want the third term, I'm going to do 4 plus 3 times 2. If I want the 20th term, it's probably going to be 4 plus 3 times 19. Okay, so where does all of this come from? So let's write this out. So in order to generate A of n, what we're going to do is we're going to take our starting value, which is 4, and we're going to add to it our what we're adding each time times the term before it. Okay, so let's take a look at this now. Let's break this down. So this here, this is the name of our sequence. And this here, This is our term number. Okay, so name of the sequence. So this is the term number. So how we say this is it's A of n equals 4 plus 3 times n minus 1. Now, once we have our formula, we can generate any term in the sequence. So let me write that down again. A of n equals 4 plus 3 times n minus 1. Okay, so if I want to find the 27th term, then this becomes n. So how do we write this? We would write A of 27 equals 4 plus 3 times 27 minus 1. Now, when you do, there's nothing to do on this side. I don't want you to think of this like an equation. I know it looks like an equation, but it's actually not an equation. It's something kind of similar. Nothing gets done on this side. All you're doing is simplifying this side. So the A of 27 stays, and then we simplify. This would be 4 plus 3 times 26. 4 plus, let's see, 3 times 26 is 60 plus 18, that's 78. So that means that the 27th term would be 82. Okay, and that's how you say that. A of 27 is 82, which means the 27th term in the sequence would be 82. Okay? Now, there's not just adding patterns. There's also multiplying patterns, right? Okay, so let's look at a multiplying pattern. Let's call this sequence F. Okay, just so you can see. So this sequence, if you look at it closely, this is not an adding pattern. This one is a times 2 pattern. That's a times 2 pattern. Okay, so let's look at our table again. So this time we have n, and this time it's going to be f of n because the name of our sequence is f. So 1, 2, 3, 4, 5, dot, dot, dot. Okay, and what did that output? 4, 8, 16, 32, 64, dot, dot, dot. Well, if you tried to figure out how to do this one, it would look something more like this. This one would actually be 4 times 2 to the 0 power. Anything to the 0 power is 1. So this would be 4 times 1. Then it would be 4 times 2 to the first power. 4 times 2 is 8. 4 times 2 to the second power. 4 times 4 is 16. 4 times 2 to the third power. 4 times 2 to the fourth power. Dot, dot, dot. So in a multiplying pattern, our function actually would look more like this. To find any term in the sequence, you would do your starting value times whatever you're multiplying by, and you raise that to the exponent that's 1 less than the term you're looking for. Okay, that was a handful. That was a mouthful. Let's try that again. To find any term in the sequence, take your starting value times whatever you're multiplying by each time, and then it's n minus 1. So whatever your term you're looking for minus 1. So how does that apply down here? Okay, well, here's our formula. I'm having trouble writing my n's today. 4 times 2 to the n minus 1. This is for a multiplying pattern. So if we want to find the 10th term in the sequence, then we would do 4 times 2 to the 10 minus 1. So f of 10 is 4 times 2 to the 9th power. This is going to be a big number. 4 times 10 equals, grab your calculator. Turns out 2 to the 9th is 512. And so we multiply that times 4. and I get 2048. So the 10th term in this sequence is going to be 2048. So we have an adding pattern and a multiplying pattern, and each of them has a formula that looks similar, but it's a little bit different.